So over the last 3 years, there's been a change in energy demand which is secular. In many aspects of that demand, I don't think we've seen at any point in time, certainly over the last maybe 5 decades. The priorities from an energy demand perspective, and they've been driven by industry and they're being driven by government, are really critical factors such as energy security. They're environmental factors. A requirement, a demand for clean energy, and they're also factors now associated with top-line energy growth. We have entered an era, and it's a very uncomfortable energy era, where top-line energy growth, particularly power growth, is growing from a pedestrian perhaps 0.5% year on year, and with the whole energy system has been very comfortable accommodating a 0.5% growth rate for a number of decades. And we've entered an era where the top line growth is more along the lines of 5% a year. Now this has created a tremendous demand for energy, and it's also created a tremendous incentive for those on the supply side to create products that are aligned with those demand requirements. Terrestrial Energy is participating in this matching of future demand with new supply requirements. Those new supply requirements, and this is what's very interesting about the nuclear sector today, it's able to deliver a supply solution which is totally distinct and unique. So in the form of a smaller modular reactor, you're able to bring perhaps half a gigawatt of nuclear energy supply, which is clean and firm, and you bring it close to point of demand. That is something that we've never seen before. We are developing a small and modular reactor, so one application of our system, as we on the supply side are providing those high value supply solutions to match future demand, is we have a small and modular reactor. When you look at the power side, it's actually not that small. We have 2 operating reactors in our standard design. Those 2 operating reactors from one plant, are able to create maybe just over 800 megawatts of thermal energy, which if we choose, and the customer chooses, to use it all for power generation, will generate just under 400 megawatts of electric power. So we can bring in one plant to an area of land no more than 30 acres, nearly half a gigawatt of clean, firm power supply. In terms of energy security, this is very important because you're not relying even further on the grid to accommodate more power. Grid reliability and grid robustness is a major theme in many policy circles. You're able to support those policy objectives by bringing power to point where it's needed. So in terms of the application, with that paradigm, this small and modular paradigm, we're able to bring our system, a small and modular reactor, requiring no more than 30 acres of land, so a tremendous amount of siting flexibility compared to conventional nuclear, and you bring it close to point of demand. And if you looked at point of demand today, if you looked at where it's coming from, that demand point could be a data center, and a very large data center as well, looking into the 2030s, and we're looking to provide the solutions, the energy supply solutions in the 2030s. If you looked at the 2030s, you are contemplating data centers requiring hundreds upon hundreds of megawatts, even gigawatts of power. You're also looking at industrial production, and we've entered an age where reshoring of industrial production, with all the energy requirements going with it, is driving energy growth in the 2030s. So we're also able to site our small and modular reactor plant, site it close to chemical plant, petrochemical plant, and also mines. It has to be a relatively large mine, but mining operations and some mining operations are very, very energy intensive. So in terms of the applications for our technology, it sits very, very well in this energy macro context. But in terms of the specific applications, we're not looking to be all things to all people. This is a massive opportunity for those on the nuclear energy supply side to innovate and create very high value solutions, looking forward in the 2030s. But we are focused on three sectors where we think the merits of our design give us a strong competitive advantage. And the first one is data centers. So the competitive advantage is the ability, this flexibility to site it, and also the capacity to provide power on a customized basis to match the reliability requirements of the data center. Now, that customization when it comes to power requirements for data centers could include the incorporation of natural gas into the mechanism that we use to supply power. And that improves resiliency, but it also improves speed to market, speed to power. This is a big theme amongst data centers. They're all racing for market share. That is one of the prime business objectives, and always has been, for the IT sector. It's achieving a dominant market share. They need power, they need it quickly. We're able to facilitate that because we're able to customize our power supply with other energy systems, including potentially natural gas. The second sector where we think we have a strong competitive advantage is the market for customized heat and power to chemical plants, and perhaps a mine, and so forth. That customization is facilitated because the unique characteristic of our nuclear technology is its capacity to deliver heat at a high temperature, so this is high quality heat, at a high temperature that makes it very, very relevant for direct use in industrial processes. And if you looked at the match between chemical processes, petrochemical processes, and some mining beneficiation processes, the petrochemical sector, there's a very good heat match. So that's the second application for our system, near located, co-located to point of demand. And the third application also is recognizing that we have probably in this country 260 gigawatts of aging coal generation. I think it's unlikely that we will have a coal boom where there will be a period of renewed capital commitment to building new growth plants. I think what's more likely to happen is those sites that are aging out, those plants that are aging out, create a great opportunity for the next generation of clean, firm power supply. Coal is very firm. It's firm, reliable base load. So the opportunity on those coal plant sites is to put a small and modular reactor on those sites. Those sites typically have a rail spur. Those sites typically have also an existing switchyard and connectivity to the grid. Those are valuable features when looking to and contemplating what the next step may be for that site, which is not the extension or a new coal plant, but rather the construction of a small and modular reactor. And at those sites, the application is to support the grid and support the grid's capacity to grow clean, firm generation, to support grid reliability, and also, importantly, for all three applications, do all this in a cost competitive and affordable way. And cost competitive and affordability is the essential objective for the innovator looking to supply the competitive solution, particularly across those three market verticals. Terrestrial Energy's small and modular reactor, we are participating in a sector where other private sector innovators are creating small and modular reactors. In terms of how we see our position in this sector, and it's competitive, as it always will be when innovators are pursuing a tremendous market opportunity. Now, firstly is the size point. The first strategic decision you need to make is how big your reactor is. Our reactor is the nuclear systems in the plant generate just over 800 megawatts thermal. If you use that for power generation, it's just under 400 megawatts of electrical energy, of electric power. That is pretty big. It's not as big as the conventional systems that run into gigawatts, multiple gigawatts when you have two reactors in one plant on one site. But it's certainly big, and in our opinion, that size means that you can pursue the big market opportunity rather than the niche one. And the big opportunity is data centers, the chemical sector, the petrochemical sector. So I think size is a competitive advantage, as distinct from others that are looking at 2, 4, 6, 8, 10 megawatt reactors. That's the world of diesel generation, or has been. That's not our sector. The other competitive advantage that we have, and this is really fundamental, if you're innovating to create a competitive product, it's about basic economics, it's about affordability, and it's about the cost competitive nature of the product you create. Our small modular reactor, and we're quite unique in the SMR sector, the advanced reactor sector today, uses a molten salt reactor technology. And that technology has 3 operating characteristics that are powerful economic virtues that give us the ability to have a compelling proposition that we can deliver an affordable, smaller modular nuclear plant, and that its power, that the power generated from it, is cost competitive against alternatives. And the reason is that with a small and modular, with a molten salt reactor technology, you have 3 operating characteristics that are powerful economic virtues. Our nuclear systems operate at high temperature, as opposed to low temperature, which is the operating conditions of conventional light water reactors. With high temperature, you have fundamentally a very, very good way to drive a steam turbine. Our steam turbine operates with an efficiency nearly 50% greater than the turbine powered by nuclear systems from light water reactor technology. Secondly, our cooling systems operate at low pressure. Low pressure eases your engineering environment and eases the safety case you need to make to the regulator. If you're using water rather than a thermally very stable molten salt as your coolant, if you're using water, you have to have a highly, highly pressurized cooling system. And that creates an engineering complexity which can be achieved, but again, it comes with economic consequences. We avoid those consequences with a thermally stable molten salt reactor, with a molten salt technology. The third point is inherent safety. Our system operates with a high degree of inherent safety. That is an economic virtue, and it's also a social license virtue too. And that compares with conventional nuclear, like water reactors, that commonly operate with a high degree of active safety. They are very, very safe, but that safety is achieved by a lot of active engineered systems, and in some cases passive safety as well, but passive safety often comes with a very significant economic penalty. We avoid all those economic problems with a thermally stable a coolant, a molten salt, and these virtues are only found, these 3 virtues are only collectively found with molten salt reactor technology. So in terms of fundamentals, using at the heart of our small and modular nuclear plant a molten salt reactor, we have those 3 operating characteristics: temperature, high temperature, low pressure, high inherent safety. Those fundamentally are the features that you need, the operating characteristics you need to have a highly capital efficient nuclear plant that generates electric power, generates nuclear power at a cost competitive point. So that's the sort of fundamental economic point about affordability and cost. There's a third point as well that I think is important. As you look at the applications that we're seeking to provide, the demand applications, the power applications that we're seeking to supply, and that is customization. If you're pursuing what I think is a very exciting paradigm of building a smaller modular reactor near point of demand, rather than relying on pipeline and transmission to deliver this energy to your customer, you have to recognize that if you're looking to serve one customer, your customer has its own set of requirements. The grid has a common set of requirements across the entire grid. But if you're looking to supply a chemical plant, a data center, a petrochemical plant, you have to customize to meet the requirements of your prime customer. Now, customization, when you're in the world of nuclear technology, is very, very difficult. What you have to pursue for economics with nuclear systems is standardization. You go to the regulator, you make your case for your nuclear systems, and the regulator, once they approve it, you're not looking to change it, you're looking to repeat the process with the same standard design. That is the paradigm for nuclear systems. However, if you want to customize, you need to be outside the nuclear regulatory envelope. You need to be customizing with non-nuclear systems. The back end of our plant, because we're using molten salt reactor technology, and because of the way it is designed, the back end of our plant, which is actually physically discrete, it can actually be separated by maybe a quarter of a mile or half a mile. The back end of our plant that creates the steam, drives the generators, that is non-nuclear. So what that means is that you can customize, you can integrate other systems, and you're doing it in standard industrial space, and you don't need to go back to the regulator to make your case that that change to the back end of your plant has impacted your safety case, and you have to reapply to the NRC. So I think that third point, sort of customization, is extremely important. I'll just say one other thing about our competitive advantage as well, and that is it's not just about delivering siting flexibility, customization of application, an affordable plant. I mean, we think we have, with the design choices and technology we've made, we think we've got the most capital efficient small and modular reactor plant in the market. I mean, this is all great, but speed to market is extremely important. Speed to market at scale. We're able, and this is a unique position that Terrestrial Energy has, we're able to deliver all these, this tremendous potential, fundamental potential of our technology, but we have a reactor system, it's a Generation 4 reactor system, and it's been powered with nothing more than standard nuclear fuel. We have a reactor system that does not require any exotic reactor fuels. We're plugging in to the supply chain that's been built up by the nuclear industry over the last 50 years. And we're also plugging in to the regulatory regime that surrounds nuclear fuel supply on a, not just in the United States, but on a cross-border basis that's been built up over the last 50 years for the peaceful use of civilian reactor technology. We're plugging into all that. We're using standard nuclear fuel, uranium enriched to no more than 5%. And in terms of scalability, we think that is a tremendous advantage. We can offer all those economically very exciting features with a power plant and reactor system that is fueled by nothing more exotic than standard nuclear fuel. In last year in 2025, you saw a further extension of excitement in Washington on the value of nuclear technology. For many years, Congress has been supporting nuclear, but the Trump administration in 2025, in May, made a number of executive orders which directed the Department of Energy to become much more engaged with the advanced reactor sector and implement programs to speed the development of these very, very exciting systems. So as a result of those executive orders, the DOE announced two programs, one for reactor pilot plants, and the other is for fuel pilot plants, the plant which you would put together on a pilot scale to manufacture the fuel. We applied for both programs. We had two awards, one from each, and we were, I think, one of only 3 awardees that secured awards from both programs. The reactor pilot is a very important program that we're now partnering with the DOE, and that program will allow us, with greater speed, greater support to our schedule, to allow us to collect the data that will be so important and is so important as you prepare your license application to the NRC for commercial operation. The fuel plant is extremely interesting because the fuel plant, we're not looking to build and operate. We're looking to supply the fuel to IMSR reactors that are operating on a fleet basis. And the fuel pilot program, which we're now participating on with the DOE, gives us the ability to accelerate the schedule for construction of that commercial plant.